Okay, so let's do another example from variation of parameter method. So we have this differential equation, and in the question they have not given us the solution for the homogeneous differential equation, so we have to find it by ourselves. Okay, so then let's write the homogeneous differential equation. Then the auxiliary equation is m square plus 1 is equal to 0. Okay, so then we have to use quadratic formula here because we cannot factorize this. The roots I will give you will come out to be complex. Okay, try to pause this and try to do it by yourself. So plus or minus I, which means alpha is 0, beta is 1. Then our complementary solution is C1 e to the alpha x is e to the 0x cosine x, beta is 1, plus C2 e to the 0x sine beta x is sine x. So the fundamental set of solution is actually e to the 0x is 1, so cosine x and here sine x. This is the fundamental set of solution. Okay, so this is y1, this is y2. Alright, so next thing that we do is, since we now know y1 and y2, we can find Wronskian. So w is cosine x y1 sine x y2. Derivative of cosine is negative sine, derivative of sine is cosine. So we have to find the determinant here. So cosine times cosine, cosine square x, minus sine times sinus is minus sine square x, which gives us cosine square x minus plus sine square x. Now from trigonometric identity rules that you have learned, I hope you have learned it before, cosine square plus sine square is actually 1. So your w is really 1. Okay, alright, so then we know w, then we can find u1 by the formula negative y2f over w is equal to dx. So I forgot to do the standard format thing because this is already in the standard form. Okay, I think I forgot to mention it. Now f is here actually x, that is the right hand side function of the non-homogeneous differential equation, which is in the standard form, right? Okay, so negative y2 is sine x times f is x divided by w is 1. So you have to integrate negative x times sine x. Now how do you integrate x times sine x? So this is where variation of parameters can be a little bit challenging, because you can be given integration by parts or integration by substitution. Okay, here, well, we have to use integration by parts. So I choose my u to be x and dv to be sine x. So then du is actually 1 dx, the derivative of x is 1. So v is integral of sine is actually negative cosine. So we can write integral of negative x sine x is negative times, this negative is from here, okay, negative times uv negative x cosine x minus v du. V is negative cosine x times du is just dx. Okay, so then the integral is negative positive x cosine x. Here negative positive times negative is negative. If you integrate cosine, you get sine. Let's forget the arbitrary constant. Let's assume it to be 0. So this is u1. Okay, alright, so that was a little bit tedious to find u1. Now let's find u2, where u2 is the integral of y1 f over w dx. Now y1 is actually cosine. So cosine x times x over w is 1. Okay, here also we have to use integration by parts. Okay, so little bit tedious. So here I again assume u to be x, dv to be cosine x, so du will be 1 dx, v is integral of cosine is sine. So the integral is equal to here u times v x sine x, uv, that is x sine x, minus v du sine x, du is dx. So if you integrate x sine x minus integral of sine is negative cosine, so plus cosine there. Plus is arbitrary constant, let's assume it to be 0. So we get u1 and u2 finally. Okay, so then what is our particular solution? u1 x cosine x minus sine x times y1 is cosine x, plus u2 x sine x plus cosine x, y2 is sine x. So that is our particular solution. Okay, so it seems to be like we can simplify our particular solution. Yp, let's expand the brackets. So x cosine square x minus sine x cosine x, plus here expand the bracket x sine square x plus cosine x sine x. Okay, here you can see x sine x, cosine x sine x cosine x cancel out, okay, because opposite signs, and here we get x cosine square x plus x sine square x. We can factor out a x, so we get cosine square x plus sine square x. So cosine square x plus sine square x is actually x. Okay, so we get the particular solution to be x. Amazing, right? You started with sine and cosine, and you all of a sudden get an answer nothing to do with sine and cosine. That is the powerfulness of simplification. Okay, so that is our particular solution. So then the general solution is c1 cosine x, c2 sine x. This is y1 and y2, the solution for the homogeneous differential equation, plus the particular solution is x. So this is the general solution. Nice, clean general solution. Okay, all right, thank you.